with reference to a part 1 video where we discussed the example of a school. Let us continue ahead. Now imagine in a school data of divisions full of students, a child comes to train and test a model that he has developed on the school data. Now, instead of choosing class C, he decided to choose class A because his model overfitted the class C's data. He developed his model using the class A data, and when he predicted the outcomes for test data on class B and C, his model again underperformed. What could be the reason now? Well, yes, it's underfitting. The model did not learn anything from the training data that is of substantial value, which means the training data had so much of variety or variance in it that there is no one particular hypothesis or one particular generalization the model could pick or the pattern a model could learn. In that scenario, what it did was it was confused in understanding the principle or the graph of that model. It's now that the student has understood he cannot just take one subset from these divisions. One would overfit, another one would underfit. The variance is either just too high or just too low, or the bias it's just too high or just too low. How can you know the underfitting scenario when you train a model? You can look at the loss of the model. It's quite high, it's never converging, it never comes down to one point, it never decreases in a pattern, it just keeps on increasing, decreasing, or it's just unstable. It never converges to a point. It's a reflection that your model is underfitting. And when you test it on the validation or the testing data as well, the error never reduces. Rather, it introduces a huge error which says the model's prediction and the real output both are quite different. So let's see what approach the student does in part 3 of this video. Thank you for watching this video. Follow for such more videos.